Hello, George.
Hello, Laura.
How's it
I,
going?
I'm all right, man. I see you're at glorious University of Southampton.
Oh, of course, yes.
It's a
This is
beautiful
our
place.
centenary building. This is building 100. That was
Very
built
nice,
to
very nice.
commemorate
It's so
100 years of
beautiful.
the university. I
I'm
actually
sorry,
quite
say
like it.
again?
Oh, sorry. This is building 100, which was built to commemorate 100 years of the University of Southampton.
All right, that's cool.
So I thought it would be a
University
fun
of
one to have.
Glasgow, though. Sorry, it looks like it.
I,
It looks like a deluxe hotel, doesn't it?
it does, yeah. Pretty nice, isn't
Well,
it?
well, you're a lot newer than the University of Glasgow, which was founded in when? 1460 something or other.
Gosh,
Yeah,
that's
we're
all
old
right.
timers over there.
You're
We're
going to
old.
end up having a building 700 soon.
Okay, so there's a, I think you got some kind of dilemma, right?
Yes, I have. No, I've only ever seen this word written down, so I don't know if I'm going to pronounce it right. But a veridical paradox, a
Say it one more
v,
time.
a veridical paradox,
I'm gonna take your word for it, okay?
veridical. It looks like veridical, so I'm going to go with that. And it's like a counterintuitive idea. Oh, all good.
I'm sorry. My good friend Emily's just now bringing me a coffee.
Look at that.
Yeah, ela do pera. My good friend Emily's got a beautiful cafe that I'm sitting on the penthouse. And
No,
right
no.
on. So
Gosh,
we're
everyone's joining in.
this guy over here, some kind of stranger, I don't know, some kind of transient. No, that's my son. Say hello.
Hello.
That's enough.
Hello.
Get rid of that gum.
Oh, goodness me.
All right, τώρα πήγαινε κάτσε φάει το τοστάκι και ησυχία φέρτε τη τσίκλα, γρήγορα, εδώ, κοιτάξτε, φέρτε εδώ, την κρατάω, I had to, δεν την πετάω, εδώ είναι, I have to hold this piece of gum, okay,
Oh, goodness me.
so it doesn't end up on somebody's shoe. All right,
Gosh.
Laura, I'm sorry for the disruption.
Not at all. I'm starting to think that's not a background screen that I can see behind you. Look at that.
It's not fake, eh? It's an actual,
Oh my gosh.
not bad, eh?
Look at that. That looks
We're gonna have
amazing.
to make it a promotional video as well for our
Absolutely.
Italianos, especially at the Neon Cafe. I believe it's Neon. No, sorry, the Soul Cafe. We got soul over here at
I
this
love
cafe.
it.
All right, I'm sorry.
Excellent.
Please.
No, well, it ties in quite well, having an infinite amount of people around you. What if there was a hotel which had an infinite number of rooms in, and it was filled with an infinite number of guests?
Okay.
That is, well, Hilbert's Hotel, isn't it? You heard of Hilbert's Hotel?
Right. With infinite, yeah, that's right. I've heard about that. Like they're trying to basically kind of talk a little bit about degrees of infinity.
Exactly.
Right.
Yes.
There's countable infinite, there's uncountable infinite. That's kind of what I remember.
Yes. And this is something that he was sort of talking about in the 1920s, about how to sort of talk about infinity and how to, think about infinity. And that's why this is one of these paradoxes that I probably aren't pronouncing very well. It's a counterintuitive result. It's true. It works on paper. It doesn't really work in real life, but that's fine. But if there was, let's say, for example, because you're on holiday right now, and you were checking into Hilbert's Hotel, but all the rooms are full. There's no vacancies, but they can give you a room. There is a room available. All they need to do is just take everyone in their room and then say, move to the room that's one up from where you are. So you're going to end up in room 1. Everyone else is going to end up in whatever room they were. Let's say it was n plus 1, which means that, yeah,
That's something that
infinity.
would work.
Yeah, exactly. So infinity plus 1 equals infinity. Isn't that cool?
That's very cool, actually. So, but there was infinite. Wow, that's so it's like we can't really treat infinity like a number, I imagine, right?
No, it's more like a concept, sort of the normal logical rules and ideas about numbers sort of break down when it comes to things like infinity. It's,
Can I ask a question?
of course.
Is that maybe one of the reasons? Oh, I don't know if this kind of ties in, but I think that lots of times when we talk about set theory and the properties of set theory,
Mhm.
things kind of change a little bit.
They do,
Talk
absolutely.
about an infinite sum
Mhm.
or an infinite progression, I guess, or an infinite sequence, or certain things that you can't really take for granted for a finite set, as big as it might be.
Yes,
All
absolutely.
right, okay, cool. Please continue.
Um, sure. Well, what if there was a bus with an infinite number of passengers on
Okay,
the bus?
that's a long bus.
It is a very long bus. They're going to be there for a while, aren't they? And what
What if they
if
ask
it,
you to sit in the back of the bus? What
oh
do
gosh, that would be a long walk, wouldn't it?
you?
Gosh.
I'm sorry, continue, please.
Well, what if this bus turns up to Hilbert's Hotel after you've already checked in? And they say, I'm sorry, there's no vacancies, but there are rooms available.
That's
And how would
weird.
that work?
That whole phrase is just weird, isn't it?
It is. It doesn't make sense. It works on paper, but not in real life. And how they're going to fit all those people in these rooms is they're going to say to all the guests in the rooms, okay, well, whatever room number you're in, double it. That's your new room. So you're going to move
All
into,
right. Okay.
yeah, so
So infinity times two is still infinity.
it is. Yep. So let's say let's take building 100 for example. Let's imagine that this is a hotel. It's not, but let's
It
imagine it
looks like
is.
it looks like a fabulous 5-star hotel.
It is one of the nicest buildings on our campus. But imagine this was a hotel and all the rooms were numbered. Um, hang on, I
What are
lost
you
my
gonna
train of
do?
thought.
Infinite floors or something or what?
No, sorry. If all the rooms in this hotel were numbered, then there would be twice as many rooms as there are odd numbered rooms. Does that make sense? So the number of odd numbered rooms is going to be less than the number of total rooms available. This isn't a finite hotel
Okay,
because
okay.
building 100 is finite.
Right.
But in Hilbert's hotel, this isn't true. And this sort of thing can be explained with Cantor's theorem, but I'm not entirely
Oh, like Cantor sets.
yes, exactly.
All right, where you take like the middle thirds and something like that.
Yeah. Yes, I'm not entirely familiar with it, so I'm not going to talk much about it.
That sounds like a cliffhanger for our next video, doesn't it?
Exactly. Yes. So, and Hilbert's Hotel, the idea and the thought process behind it is because, we have this actual infinite. It's an idea, but it's an actual concept. It's an actual value, and even if just thinking about it quickly, it doesn't make sense, but actually, it does make sense.
It does make sense when you think about it, eh?
Yeah, I'm not too sure how to say the best thing about that, really.
That's okay. It's
But
okay.
there
I
we
mean,
go.
it's a concept. Again, of course, it's an abstract concept.
Mm.
Talking about infinity, generally, just generally, a lot of people say, well, yeah, you can take one, you can add another, you can constantly add and get a bunch of numbers, infinitely many numbers, but countable,
Exactly.
right? But there also is, right, certain sets that are, or let's say as an example, the real number line, or not even the whole real number line, but just the interval between 0 and 1,
Mhm.
right? That's filled with real numbers, which are uncountably infinite. And I think there's a
Yes.
few different proofs that you can kind of use to show that there's that they happen to be uncountably infinite. But in a sense, um, as here's where I kind of like my eyebrow would kind of raise when I heard this. I'm like, okay, I
Yeah.
totally agree that the integers are countable. You know, there's no values in between. So I kind of thought to myself, if you could take any 2 points, discrete values, and there's nothing in between to talk about, and you have infinitely many of those, they're countable because you can set up a one-to-one correspondence with the integers, the positive integers.
Yeah.
But then also, if you look at the interval between 0 and 1, you can say to yourself, all right, pick a value. There is a value in between 0 and 1 because let's say it's a half.
Mhm.
Okay. Now there's infinitely many, 1/2 being a rational number, an integer over an integer. But between 1/2 and 0, let's say there's 1/4. Between 1/2 and 0, there's I should say this way. 1/2, 1/3, 1/4, 1/5. You keep getting, you can, just take 1 over all of the positive integers and get infinitely many. So I'm gonna put this, see if you can, under pressure, and see if you can answer this question.
Sure,
I know you
give
know the
it.
answer, so there's not a lot of pressure. But are the rational numbers, if I took 1/2, 1/3, 1/4, is get as many as I want in that small interval between 0 and 1, would you count that countable or uncountable?
I want to say that it is countable.
It is countable.
Okay, good.
See that? That's why I have confidence in you. I knew that you were going to get it right. I knew it.
Oh, thank you very much.
Because what we can do is we can set up my baby boy right now is about to stick his gum somewhere where he's not supposed to. And if I yell out, and scream out, please forgive me.
That's
Lord,
fine.
forgive me, and anybody who's watching, forgive me.
That's fine.
But you can kind of set up, and I believe this is really just hand waving more than anything else. You can set up kind of a whole, like say 1 over, let's say 1 over, as an example, 1/1, 1/2, 1/3, 1/4, 1/5. Then 1/3, 1/4, 1/5, and so on. Okay, so you can set up an infinite array of these numbers, but then you can kind of take a diagonal path and see that you can count them, even though there's infinitely many numbers between 0 and 1/2, like 1 over a million. That's going to end up somewhere way down on the line, but it will be represented. So that would be, again, countably infinite.
That's really cool.
Even though it's not something that we might think that, like the natural numbers or the positive or even the integers collectively, positive and negative integers. But if I asked you about the irrational numbers, are those countable? Are they countably infinite? Countably, is that? Or uncountably infinite? Are they countable or uncountable?
I think it would be hard to count them. I think we can make an attempt, but it wouldn't quite work. Wouldn't quite work out.
I'm getting a phone call from Coventry.
Oh, okay. What do they want?
Should I answer it?
Go for it.
Hello? Oh, okay. It's a machine. Never mind.
That's disappointing.
Trying to get hold of us humans. So, Tsikla, είπαμε τη Tsikla, όχι έτσι, θα κολλήσει, φίλε. Sorry. So, and then I think Cantor sets also kind of talked a little bit about sets that are uncountably infinite, where I believe you take an interval, then you remove you leave like 3 intervals, I believe, and then you break those up into 3 and then those up into 3. So we might be able to talk a little bit about that maybe in our next video.
Let's do it.
All right, we're going to do it, man. We're going to do it for humanity.
Excellent. I'm going to have to do a little bit of research first.
I'll be honest with you, even though this is work, it feels more like a holiday.
Excellent. I appreciate the hustle.
All right. So I think, are we signing off? You're the boss.
We can sign off, sure.
Okay.
One thing I was thinking about mentioning, although maybe this is a future video idea, is that of course there are other of these paradoxes that I'm probably not pronouncing right. Things like the Galileo paradox, the Banach-Tarski paradox. Maybe we can do those in the future.
That sounds good to me. We're always like, it's too many paradoxes, it seems like, or paradox. Is paradox is the correct way, the correct plural?
I have no idea, actually. I don't know. I enjoy a good paradox.
That too, when we get back.
Let's do it.
Oh, Laura, it's always a pleasure. Believe me, this is a lot of fun. I can hardly call it work.
Fantastic.
So,
thanks so much, George.
All right. So I don't know if baby boy wants to say bye. You want to say bye? Say bye. Say bye to Laura. Bye? Say bye to hey. Say bye to Laura.
Bye bye.
We'll talk to you soon.
All right.
Bye. Vedi me ragazzi, cazzo è fuori qua.